what I'll do is I'll kind of skip through the problems that I don't think need that much review. And I will say that number one is just combining like terms. So that's not something that I think we need to review. But I will go over number two just because I think that one's slightly interesting. So let's look at number two. It says, the graph above shows the positions of Paul and Mark during a race. Paul and Mark each ran at a constant rate, and Mark was given a head start to shorten the distance he needed to run. Paul finished the race in 6 seconds, and Mark finished the race in 10 seconds. According to the graph, Mark was given a head start of how many yards? So the graph is very clear in whose line belongs to Mark, and it's this one, the green one, because Mark is literally on that line. And as for figuring out a head start, it's really kind of just looking to see like the y-intercept, I would say, only because if you're not given a head start, you're kind of starting at 0, which is why Paul starts at 0 over here. But if you are given a head start, then it's like you already traveled some without having like experienced any time yet. That's what a head start kind of is. So when you look at it, you can kind of notice that the head start is between 12 and 24. And the only answer that's between 12 and 24 is C, 18. So that's the first problem for this section that I wanted to do. And I thought it was kind of interesting because a lot of the time it's not really a math test, it's just an interpreting graphs test, which is it goes into any field really. So let's look at the next page. Let me clear this. All right. So I want to do number 3 too, just because I think graph questions are a good review. And yeah, so let's see. It says snow fell and then stopped for a time. When the snow began to fall again, it fell at a faster rate than it had initially. Assuming that none of the snow had melted during the time indicated, which of the following graphs could model the total accumulation of snow versus time? So it's really just about reading the problem stem and then kind of translating that into a graph. So the most important thing I would say about this problem is that it does you kind of have to like use process of elimination to get the best one. And I know for a fact it can't be C because it never said that the snow was melting. And the only way for the level to decrease is it for it to melt or to be like scooped away or something like that. I will also say that it can't be D either, because that implies that it was a constant rate throughout the entire duration, but it tells you that it was falling and then it kind of stopped and then it fell at a faster rate. So there's more shakiness there. The next thing is just interpreting between these two. And I would say it's choice A because it's very specific when it says that it began to fall at a faster rate than it had initially, meaning that the second time that snow was falling, it had a much steeper slope. So as you guys can see, this slope over here is steeper than this one. So the best answer is A. I'm gonna move on to number 5 because number 4 is just like a simple equation problem. With number 5 though, it's just about kind of manipulating. So it says, which of the following inequalities is equivalent to the inequality above? The one thing I noticed about this one was that this wasn't as simplified as it could have been. And I noticed that every term over here could be divided by 3. So when you do that, you get 2x minus 3y is equal to 4. Sorry about that, is greater than 4. And when you do that, you can kind of notice that it's choice B. So this is a very easy problem, but it's just about noticing when things need to be simplified pretty much. And you'll notice that a lot of the times, the questions will be asking for the most simplified form. So let's look at trying to think of the best ones to do. I like number 6 because it kind of relates to statistics. So let's see. And I'll do number 7 too because it's also relating to stats. So it says the table above shows a summary of 1,200 responses to a survey question. Based on the table, how many of those surveyed get most of their medical information from either a doctor or the internet? Well, we know that there's 1,200 people being surveyed. We're trying to find the amount of people who chose doctor or internet. So we're really focusing on these 2 percentages. When you look at those, it's really clear that the amount of people that were surveyed from that amount is really 76%. So when you multiply 0.76, which is another way to represent 76%, of course, times 1200, you should be able to get your answer right away. And when you do that, you should get 912. It's just about knowing what they're looking for pretty much. And we know that they're looking for doctor or internet. That's 76% of the people who were surveyed. So we have to find 76% of 1200, and the answer we get is the amount of people that chose those. So it's simply 912. Let's look at number 7. The members of a city council wanted to assess the opinions of all city residents. At least when I'm doing stats, I like to highlight those important things about converting an open field to a dog park. The council surveyed a sample of 500 city residents who own dogs. The survey showed that the majority of those sampled were in favor of the dog park, which is the following is true about the city council survey. All right. So the one thing that kind of like hits me with this problem is that they want the opinions of all city residents, yet for some reason they only sampled city residents who own dogs. City residents who own dogs are very clearly biased because they are more likely to want a dog park for their own dogs. They didn't get the opinions of those who don't have dogs, who might not, care about something like that. So the only answer that kind of makes sense, well, choice A, you can't apply that. It has to do with your sample biases, and since this sample is very biased, you can't apply it to all of the city residents. I don't think it's choice B either, because they already included enough people who are dog owners, and we want people who are not dog owners so that it's as representative as possible of the city population. And then for choice C, that's also wrong either, because that's like the other end of the spectrum. You want a sample that is very representative of everyone. It should have some dog owners, it should have some people who don't own dogs. So the best answer is D, because it is biased and it's not representative. So hopefully that makes sense. You're gonna see, I noticed usually one question on every SAT test that has to do with like sampling and experiments and things like that. So it's always good to just know those practices. Moving on to the next one, another probability question. So I'll do that one too. All right, so it says the table above shows the flavors of ice cream and the toppings chosen by the people at a party. Each person chose one flavor of ice cream and one topping. Of the people who chose vanilla ice cream, what fraction chose hot fudge as a topping? So we're looking, oh, sorry about that. I took off, sorry. So we're looking at the people who chose vanilla ice cream pretty much. And we can tell because it says of the people who chose vanilla. So we're only looking at this column. So out of the people who chose vanilla, there's 13 people. What fraction chose hot fudge as their topping? Well, 8 out of the 13 chose it. So it's simply D. Again, you'll notice that a lot of these questions are not extremely hard, but it's always good to just get those out of the way and do them really quickly. Let's look at number 9. So it says the total area of a coastal city is 92.1 square miles, of which 11.3 square miles is water. If the city had a population of 621,000 people in the year 2010, which of the following is closest to the population density in people per square mile of land area? So this is a simple division problem, but the one thing that you have to do is isolate this area of water. And it's telling you that out of the 92.1 square miles of the city, 11.3 is just water. People don't live on water, at least now. So it's unrealistic to kind of include the water area in that representation of people per square mile of land, because people don't live on water. So you have to subtract the 11.3 from the 92.1. And then when you get that, now you can find the divide and figure out how many people there are per square mile. So in reality, there's really only 80.8 square miles of land in this city. So in order to figure out how many people there are per square mile, you get 621,000 divided by 80.8. And when you do that, This is something, of course, I would highly recommend to do in your calculator. You should get an answer close to 7,685, which is pretty much choice B. It's telling you for the closest one. So that's how you do this problem. And let's move on, just so we can get more done. I'm gonna do I'm gonna do number 10. Number 11 is another system of equations, so I think we can do that one separately. But number 10 was interesting, and it's just about kind of learning how to represent these hypothetical situations with variables. So looking at number 10, it says between 1497, I mixed those up, and 1500, Amerigo Vespucci embarked on 2 voyages to the New World. According to Vespucci's letters, the first voyage lasted 43 days longer than the second voyage, and the 2 voyages combined lasted a total of 1,003 days. So how many days did the second voyage last? So I will say that it's really good to represent unknowns as variables, so x, and we have 2 unknowns in this situation. We have the first voyage and we have the second voyage. So I'm not going to write that out. I will. So second voyage. So it's telling us that the first voyage lasted 43 days longer than the second voyage. So if we represent the second voyage as just letter x, the first voyage would be x plus 43 because it's 43 days longer than this value. And it's telling us that these 2 combined is equivalent to 1,003 days. So now what we can do is we can have x plus 43 as our first voyage, x as our second voyage, and we can set it equal to 1,003 and just solve as we normally would. When you do that, you end up getting 2x, and then I'll move the 43 over to the other side. When you do that, you get 960, and then when you divide it by 2, you should get 480. We get that x is equal to 480. Our second voyage, we know, is just x, just from how we defined it at the top. So how many days did the second voyage last? We know it's just x. X is 480, so the answer is B. Oh, where did I get the 2x from? Okay, so I got the 2x because let me make it clear, just because I know I kind of crammed it into the side. It's x plus 43 plus x is equal to 1,003. I combined like terms and I got 2x plus 43 on this side and 1,003. You're adding the x's of both because you have to add the x from the first voyage and of course the x that's representative of the second voyage. So it's 2x plus 43 is equal to 1,003. And that's, I think, the most logical approach of finding this problem. I think that of course that you could kind of do this in your head if you really wanted to, but at least this way it gives you like the surefire answer. So hopefully that made sense, and I'm gonna move on to the next page. Okay, so this is another graph problem. So since we haven't done a lot of them, at least during these sessions, I'll go ahead and do I'll do all the ones in this set, just because it's important to understand the graphs. So basically it's giving you a graph of sunflower height over time. The only important thing is that the x-axis is t days, the y-axis is h in centimeters, which is how tall they are growing. Number 12 says, over which of the following time periods is the average growth rate of the sunflower the least? So it's growing during each period, but you have to see which time the slope is the smallest, because when the slope is the shortest or the least steep, then it's going to be growing the least. When the slope is the most steep, it's going to be growing the most. So let's just kind of go through each little area and kind of figure it out for ourselves. So from 0 to 21, that's like this. I will say that I'm kind of keeping an eye out for this section over here. So it's very clear that that section is definitely the least steep. So if one of our choices encompasses that section, then that will be our answer. So at the moment, 0 to 21 seems relatively normal. So I'm going to move on to the next one. I don't think it's that choice. 21 to 42. again, 21 to 42, they're very close to each other, I guess. The first section is slightly steeper, but again, it's not by that much. So again, I don't think it's that one either. I think that one's actually the most steep. 42 to 63. It's getting less steep, I will say that. But now that we've kind of ruled out every other section, I know that 63 to 84 is this one over here, and that has to be the answer because that's the least steep out of all those. Going to number 13, it says the function h is defined by h of t is equal to a t plus b, where a and b are constants. It's in slope-intercept form, and it models the height in centimeters of the sunflower after t days of growth during a time period in which the growth is approximately linear. What does a represent? So a is the slope. It's slope-intercept formed, and we just have to pretty much pick the answer that represents slope. So let's look at each answer. The predicted number of centimeters the sunflower grows each day during the period. I like that answer only because it kind of represents like a growth factor, and it's telling you each day. So it's telling you that it's growing a constant amount each day. So I like that one so far. B says the predicted height in centimeters of the sunflower at the beginning. That would be a y-intercept, so that's definitely wrong. The next one says at the end of the period, A doesn't represent the end of the period. A represents the slope, so it's not that. And the last one says total increase. Total increase you can't represent it just from a slope. A slope is like a continuous increase, not a total increase. So A is the best answer. And what I'll do now, instead of doing the last one because it's just a linear representation, I'm going to do number 16 because that's a good geometry review question. So it says triangles ABC and DEF are shown above. Which of the following is equal to the ratio of BC over AB? Now, important, the reason why we can set up a ratio in the first place is because these triangles are similar. How so? So what I'm going to do is I'm going to write this triangle over here in like with the proper measurements, because just from using triangle logic, which is that all the angles add up to 180, we know that this missing one over here is 58, this one is 32. So by AA similarity, angle, we know that they're proportional and they're similar. So but remember what I was saying, you can only set up a proportion if the sides that you're matching up kind of go hand in hand with one another. So DF would have to go hand in hand with BC because those two, that side is what connects the 58-degree angle and the 90-degree angle. You can't connect it with this one over here because for this triangle, I'm going to call it triangle A. I'll call triangle this one D. Triangle A, this side over here connects 32 and 90. This one connects 58 and 90. So you can't connect those sides with one another. So what I like to do, just to make it clear, let me erase all these extra things that I wrote. So just for your sake, if you kind of have like a hard time like moving the triangle around and figuring that out, you can of course just rewrite the triangle, but similar to what it looks like in this picture. So this is 58 degrees, so I know that B is where the 58 happens, and I know that 32 is the only other option for A. So this is what it would look like. So it's telling us which side is equal to the ratio of BC, which is this side, over AB. So BC is that 58-90 side. AB is the hypotenuse, so 58-32 side. We have to pretty much now find and look at this picture to figure out which ones line up. Well, BC and DF line up because those two are the sides that connect a 58-degree angle and a 90-degree angle. So DF would be on the top. And then for AB, we have to pretty much just write the side of the hypotenuse, which is going to be the 58-degree and the 32-degree side. So with that knowledge, it would be DE. And the only answer that represents this outcome is choice B. So hopefully that made sense. A lot of these geometry questions are easy if you remember how to do it. And I know that since it's such an old topic, we kind of forget. So hopefully that kind of brought back some old geometry processes in your mind. Let's go on to the next page. So again, my priority for all these sessions is to get to the long responses. So I'll skip this problem set for now, just because it'll take us a while to get through all three. I will say that number 20 is not too bad either. Okay. So how about we do number 22, because that's also covering stats and medians and things like that. So in 2008, there were 21 states with 10 or more electoral votes as shown in the table above. Based on the table, what was the median number of electoral votes for the 21 states? So I will say that when you're trying to find the median, it's definitely easier to just use like the logic behind it instead of like writing every single value out and circling the middle value. That's gonna take too long. So when you have 21 states, I will say that when you have 21 states and you're trying to find the center value of the 21 states, their center value should be the 11th value. And that's because you're gonna have 10 values over here, another 10 over there, but the 11th value over here is gonna be what your median is. So basically what you're gonna be doing is you're gonna be using this chart to find the 11th value and kind of figure out under which column it lands under. And that's really the quickest way to find it, because coincidentally, all this chart, it numbers all the values in numerical order. Remember that when we're finding the median, we have to order the numbers in numerical order. So it kind of already does that for us. So now it's just about figuring out where the 11th value would land, and that's our answer. So I know that values 1 through 4 are under 10. Values 5 through 8 are over here. This would be the 9th value. This would be the 10th value. The 11th value would be somewhere over there. So it's really good that it was under a spot where, it's very open and broad, because now we know that the 11th value is somewhere under the frequency of 3, which is 15 electoral votes, which means that our median is 15. And that's really the easiest way to do that problem. If the problem was asking you for the mean, then I would say you might want to add up every single one and divide it, because really mean is that's the quickest way to do it. But medians, if you kind of understand the logic behind it and know which value you're looking for, it should be a little easier. So moving on to the next page, let's see. I will say that number 23 was interesting, but it was kind of easy. So let's look at number 24 at least, because we haven't really done a lot of percents. So it says a customer's monthly water bill was $75.74. Due to a rate increase, her monthly bill is now $79.86. To the nearest 10%, what percent did the amount of the customer's water bill increase? There are many ways to do this, but in order to find a percent increase, normally what I do is I divide the bigger value over the original value. It's really the original value that always goes on the bottom. When you do that and divide those numbers, you should get, let me just put in my calculator really quickly, you should get 1.05439, a whole bunch of numbers. That's just pretty much telling you that it's 105% of what was there, but really what you're looking for is just this part over here. It's telling you that what increased was, of course, the 75 that you have there, but what you're looking for is the percent increase from these transactions. So this over here, the decimal points, not the one in the front, this will tell you what percent increase was actually occurring. And from the looks of it, it ends up being like 5.4% of an increase, because it says to round it to the nearest 10th. So, and remember that the decimal point will go over here when you're converting it to a percent. And since the 3 doesn't make the 4, we wouldn't round up. So it just end up being 5.4%. So D is the answer to that problem. And what I'll do, since number 25 is just a linear equation, what I'll do is I'll actually do number 23, just because that one was kind of weird to think about. So it says, as part of an experiment, a ball was dropped and was allowed to bounce repeatedly off the ground until it came to a rest. The graph represents the relationship between its height and time, and after it was dropped, how many times did the ball have a height of 2 feet? So basically all you're doing is just counting how many times it crossed that 2 feet mark. I see it once, twice, 3 times, so the answer is 3. Again, a lot of these are interpreting graphs, and just kind of make sure that you're looking out for every single time it crosses. And that's what I would say for this problem. Moving on to the next set. 26 was a really, really interesting problem, so I'm gonna do that one. It was definitely one of the hardest problems I've seen on an SAT test, because it was really weird to think about. So 26, it says a gear ratio R to S is the ratio of the number of teeth of 2 connected gears. The ratio of the number of revolutions per minute of 2 gear wheels is S to R. So in the diagram below, gear A is turned by a motor. The turning of gear A causes B and C to turn as well. So if gear A is rotated by the motor at a rate of 100 RPM, what is the number of revolutions per minute for gear C? So the first thing, we're not going to really be using this because it's not relevant to this problem. The ratio we're going to be using is the number of this one, S to R. And I guess that first stem over there was just making it clear that R and S are like the number of teeth that the gear has, which each little gear tells you. And pretty much what the second one is telling you, S to R, is telling you that the ratio of this one, like you have to flip them pretty much. So the ratio, it's telling us that we're basically what we're doing. We're using the 100 RPM for gear A, and we have to kind of use it to get what gear C would be. So let's kind of use the logic of the S to R ratio. So using this one, we know that the ratio is normally going to be R and S because it's just going in the order of what it would be. However, when I saw this problem, I noticed that the ratio kind of flipped. So the new ratio is going to be S to R. And basically what it's telling you is that that's just kind of how it would be going. So the first ratio of these 2 gears, we have to do A and B first before we do B and C, and then that's how we'll find it. So using A and B, I know that the ratio is 60 to 20, right? Just by plugging those in. And when you do that, you should end up getting like 3 to 1. So basically what it's telling you, and this is important, it's telling you that for every 3 revolutions that gear A does, gear B will do only 1. So if gear A did 100, then gear B did 100 over 3. So that's our first tip. It's kind of confusing, I will say that, but that's kind of the best way to interpret it, I would say. And now I'm gonna erase this work, and what we're gonna do is we're gonna find the ratio between gear B and gear C, because we know now that gear B is doing 100 over 3 RPA, or RPM, sorry about that. So our next ratio, it would be S to R. With this logic now, our R would be over here, our S would be over here. So now our 10 would be over here, and our 60 would be over there. So now we know this is a ratio of 1 to 6. So using this logic, for every 1 revolution that gear B does, this one does 6. So it's really 6 times the revolutions of what's over here. So we know that gear B is 100 over 3. We know that gear C would just be 6 times of that. So when you do 6 times 103, and that's kind of unclear right now, I'll do it at the top. When you do 600, or 6 times 103, 100 divided by 3, you get 600 over 3, you get 200, and that's the answer to this problem. I will say that this question, I know it's really confusing. It took me a really long time to kind of figure out what the ratio and how to how to use it in this problem, only because it is like a very weird ratio. But I will say that once I understood it, it kind of clicked and I was able to get 200. And again, I will stress that there are going to be many weird problems like this that just require like math logic instead of actually knowing how to do it, because I can assure you that we've never really seen gears and ratios like this in our math subjects ever before. So this one is a really weird problem. So what I'll do now, and hopefully that kind of made sense. So I'm looking and I want to move on to the long responses, of course. So let's do those. So I thought 31 was kind of an interesting one to do, but it took me a longer time, so I have to kind of figure out an easier way to do that. So I'm not going to waste your time with that one right now. And number 32 is just combining like terms, so that one shouldn't be too hard at all. Moving on to 33. This one had a lot of freedom, so I'll do this problem just because it was interesting to think about. So it says, a laboratory supply company produces graduated cylinders, each with an internal radius of 2 inches and an internal height of 7.5 inches and 8 inches. So there's no real definite height, pretty much. What is one possible volume, rounded to the nearest cubic inch, of a graduated cylinder produced by this company? So basically, you just need to know the formula for volume of a cylinder, which is at the beginning, but I'll just write it here just for time's sake. It's V is equal to pi r squared over times h. The base times the height, pretty much. The base is a circle, the height is of course the height. So now there's a lot of freedom, I would say, and why I'm saying it is because all you need to do is plug in a height between 7.75 and 8. So you can really put whatever you want as long as it's in between those. And just remember that the radius is staying the same. So when you plug in the radius, it's 2. And the height, I just put 7.8 because it was the closest one. And it seemed like a somewhat friendly number. Now is when I would totally recommend you do that in your calculator. You get V is equal to pi times 4 times 7.8. You can do that in one run in your calculator. And at least with these particular numbers, you could have put your own. You should get like 98.01, but it's telling you to round it to the nearest cubic inch, so it's just 98. And that's one of the many answers to this problem. If you tried another value, they should be relatively close to 98 or in the 90s, the high 90s. So that's the only tip I would say for this. All right. So going to number 34. Let's look at that one. In the xy plane, the graph of y is equal to 3x squared minus 14x intersects the graph of x at the points 0, 0 and a, a. So what is the value of a? So I will say that really what you need to know is that when they intersect, x will be equal to 3x squared minus 14x. It's basically telling you that when these two whenever these two equations are equal to one another, they're going to be intersecting, and that's going to be the points when they're the same. When you do this, and you should definitely get x as one of your intersecting points because it intersects at 0, 0, and whatever we get for a. So what I'll do now is I'll just plug in a just because that's what we're looking for. And really a, x, it doesn't matter because in this problem in particular, it's telling you that a and a are the same for x and y, so it doesn't matter. When you do this, I would say you can move over the a to the other side. You get 3a squared minus 15a. And I would say when you're attempting to factor this, it's easier to just divide by 3 now, because when you divide by 3, it just becomes more simplified. So by dividing by 3, you get a squared minus 5a. And this is very easy to factor. When you do that, you bring the a to the outside, and you're left with an a on the outside and an a minus 5 on the inside. So going back to what I was saying over here, and I'll write at the top just so there's more space, we know that a has to be equal to 0 from this one. A minus 5 has to be equal to 0. A is equal to 5. So our last value of A is 5. And it checks out because we are able to get the 0 again, which was proven in the stem of the problem. So yeah, this one wasn't too bad, I think. But let's move on to the next problems that are there and see how many we can do. I will say that this one isn't too bad. For number 35, just whenever you have an x-intercept, remember that your y is equal to 0. The x-intercept of a graph is like this, and it's like over here, it would be there. The y is 0. So all you have to do is plug in 0 for y, and then you should get it right away. So I'm not going to bother doing that. But let's look at number 36, because that's also kind of an interesting problem. So it says, Andrew and Maria each collected 6 rocks, and the masses of the rocks are shown in the table above. The mean of the masses of the rocks Maria collected is 0.1 kilogram greater than the mean of the masses of the rocks Andrew collected. What is the value of x? So when I saw this, the first thing I did was I figured out the mean for Andrew, because we know that Maria's mean is only 0.1 kilogram greater. So once we get Andrew's, we can just add the 0.1, and from there, things should be clear. So when you take the mean, remember you have to add up all the values. 2.4, that's a 2.5, 3.6, 3.1, 2.5. It's definitely tedious, but it shouldn't be as bad when you're putting it in your calculator. And you divide it by 6. And when you do that, I'm pretty sure you would get 2.8, just to speed up the process. So we know that Andrew's mean was 2.8, and from this problem stem, we know that her mean is 2.9. So let's kind of figure out what x is now. So using the same concept of mean, remember there are 6 values. We know that all the values divided by 6 will give us 2.9, because that's her mean. And pretty much what we're doing now is we're solving for x. So we have to add up x plus every other value that's there. And then all you have to do is kind of move things over and solve and isolate x. And that's how you'll figure out her value. The first thing you have to do is get rid of that 6 in the denominator. So multiply 2.9 times 6, or do 6 on both sides to cancel that out. When you do that, you get 17.4. And what I'm going to do is I'm just going to go ahead and add all these up, because I'm not going to just subtract each one individually. It's easier to just add them up and subtract them all at once. So when you do that, your value should be 14.8. I am pretty sure that's what you should get. And when you have 14.8 over here, you just have to subtract it from both sides. And when you do that, your answer is 2.6. So that's the missing value that was represented as x in the problem stem. Let me clear the screen and attempt to do one more. So it says, I thought 37 was interesting to do. So I'm gonna go ahead and do that one. So it says, Jeremy deposited X dollars in his investment account on January 1st, 2001. The amount of money in the account doubled each year until Jeremy had $480 in his investment account in 2005. What is value of X? So maybe there's like a formula to use when doing this. I thought it was just easier to sorry about that, I dropped my pen, to kind of write out the years of this problem. So he starts at he's really, what the years that we're looking at are 2001 to 2005. We know that he had $480 in 2005. So it's easier to just cut your amount in half, because we know that each year it's being doubled. So by cutting it in half each year, kind of doing the reverse, I think that's the easiest way to get 2001 value, because that's what we're looking for, X dollars, what his original investment was. So when you cut this in half for 2004, you get 240. You get 120 for 2003, you get 60 for 2002, and you get $30 for 2001, and that's your answer. We have 2 minutes left, so let me try to do 38 too. It says, a school district is forming a committee to discuss plans for construction of a new high school. Of those invited to join the committee, 15% are parents of students, 45% are teachers from the current high school, 25% are administrators, and the remaining 6 individuals are students. How many more teachers were invited to join the committee than the administrators? I'm not going to say school and district. That's very tedious. So, what I would say is, in order to figure out how much are in each like group, you need to know the total value, because remember, it's very easy to convert a percent if you have the total value that's there, but we don't know that. So let's try to figure that out. Well, we know that the remaining 6 individuals are students, and all we need to just figure out the percent of those students to figure out what group it belongs to. I know that 15% were parents, 45, oh, that's really, really poorly written. 45% are teachers, and 25% are school and district administrators. So by adding up all those percentages and using the complementary rule, because we know that every percent has to add up to 100, we know that this is 85. So we know that 15% of the people in the group were the 6 individuals. With this logic now, it's easier to figure out, because now we can set up a proportion and figure out how many were in the group in total. Because if 15% out of 100, the logic behind this, of course, is that 15% out of 100 would be the same as 6 over a certain group, because 100% is all the group as a whole. When you do that, it's pretty easy to do it in your calculator, but we get that the entire group as a whole consists of 40 people. So now it's relatively easy to figure out how many were teachers, how many were administrators, and then it's telling us how many more. So we have to subtract those when we get those values. So let me erase this. And now that we know that there are 40 people in the group, we would do 40 times 40.45 to get that there are 18 teachers. And then we would do 40 times 0.25, 25%, to get that there are 10 administrators. So when we subtract those two, we get that there are 8 more people in the teacher group than there are in the administration group, and 8 is the answer. So that is the end of this session.